Hi guys, in today's video we're going to look at the electrolysis of solutions, arguably the most complex part of electrolysis. And the reason it's difficult is because it's in solution, meaning there's multiple ions present, multiple positive ions and multiple negative ions. So it's really tricky to decide what ion goes where. But hopefully in today's video we'll clear that up for you. Let's start by having a look at what a solution is. It's basically a substance dissolved in water, and here I've got sodium chloride and water. Now your sodium chloride, when put in water, will dissolve and the ions will become free. Hopefully you remember that from other videos. And what you'll get, if I just put the pen on here, is you'll get Na plus and you'll get Cl minus. Now water also dissociates in solution and it forms H plus and OH minus. Now water will always form these ions, so it's useful to remember H plus and OH minus. It will never change. So you can see here we've got two negative ions and two positive ions. How do you know which one is going to go to the negative electrode and which one's going to go to the positive electrode? Well, luckily there's a set of rules to follow, and I've put them into this flow chart here. Now this is well worth remembering because it will make aqueous electrolysis that much easier. So let's have a look at what happens at the positive electrode, the anode. Well, you need to look at the anions, meaning the negative ions. Now, if you can see a negative ion that is a halide, so like Cl minus, Br minus, then you will always form the halide gas or the halogen gas. The halides will combine to form a gas. If there is no halide ion present, then you're just going to get oxygen gas. You don't need to know why, you just form oxygen. Now, if we look at the other side though, the negative electrode, you need to look at the metal you have in solution and decide, is that metal more reactive or less reactive than hydrogen? If it's less reactive than hydrogen, then you get the metal. If though it is more reactive than hydrogen, then you just get hydrogen gas. Now, you are going to have to know the reactivity series in order to be able to do this. It's useful having that printed out at the side of you as you're going through this video, or perhaps open on Google so you can refer to it. Over time, you will be more comfortable with it and you will learn it just instinctively. But it is definitely worth learning alongside this. Let's have a look at an example. And we're going to use sodium chloride, the one we've been looking at. We know that you get Na plus and Cl minus from the salt, and H plus and OH minus from the water. Now, to decide what goes to the positive electrode, we use those rules. Is there a halide ion present? Yes, you've got the chloride ion, the Cl minus here. So we form chlorine gas. Now, I am going to do the half equations for these just for completion, basically, ready for the next video. So we know we form chlorine gas. To do that, we start off with two chloride ions, and each chloride ion will lose an electron to form the chlorine gas. So we do chlorine gas plus 2 electrons. Now let's have a look at the negative electrode here. Well, the metal here is sodium, and I know that sodium is much more reactive than my hydrogen, so I won't get the sodium. Instead, hydrogen gas will form. So we'll get H2 gas. And the half equation for that, well, the H2 gas forms from H plus ion, and I need 2 of them because I've got 2 hydrogens on the right here, so I need 2 on the left. Each will gain an electron, so plus 2 electrons, and that will form my hydrogen gas. Again, please don't worry if that was a bit quick. There will be another video on half equations coming. Let's have a look at another example. We're going to look at the salt copper sulfate. So here it is. And it will break down to form Cu2 plus and SO4 2 minus. If you don't know how those form, that's also okay. Like the reactivity series, you'll get used to using it over time. So it's also useful to perhaps have another tab open with a list of common ions. That way you can keep referring to the reactivity series and the common ions when you need them. Ions from water, that should be easy now, that never changes. It's H plus and OH minus. And we're going to look at what forms at the positive electrode first. Well, I can't see a halide ion. So the rule is if there's no halide ion present, then it's oxygen gas that forms. The negative, well, copper, the metal, is less reactive than hydrogen this time, only marginally, but it is less reactive. So we form the copper solid. And again, I'll show you the half equation for this just for completion. So the copper ion, the C2 plus ion, takes 2 electrons to form copper solid. Now, I've got some for you to have a go at here. I've got the reactivity series on the left, and as you see, everything above this red hydrogen here is more reactive than it. Everything below it, so copper, silver, gold, and platinum, is less reactive than it. What I want you to do is look at these 3 compounds and decide, well, what's going to be formed at the positive electrode and what's going to be formed at the negative electrode. And before you pause the video and have a go, I'm going to make it slightly more easier by giving you the formulas. So you've got calcium bromide, you've got zinc sulfate, and you've also got magnesium chloride. So pause the video, have a go, and then unpause it for the answers. Right, hopefully you had a go. If we look at number 1, we're going to do Ca2+, that's the calcium ion, the 2 bromide ions, and the H+ and OH from water. So at the positive electrode, I can see a halide ion, my 2Br-. So that will form bromine gas there. And at my negative electrode, well, calcium is much higher than hydrogen. So we won't get the calcium, instead we'll get the hydrogen gas forming. Let's have a look at number 2. Zinc sulfate, that will break down to Zn2+, SO4, 2-, and my H+ and OH- again. So at my positive electrode, this time there is no halide ion present, so I just get oxygen gas. And at my negative electrode, zinc, well, the metal is still higher than hydrogen, so I get my H2 gas again. Let's have a look at the final one. I'm just going to clear this writing. And we're going to look at number 3 now. So number 3 was magnesium chloride. So Mg2+ and 2 chloride ions, H+ and OH- from the water. So at my positive, I have here 2 chloride ions, so they will form my chlorine gas. And at my negative, my magnesium, well, is still higher than hydrogen, so I get my hydrogen gas. Hopefully that was a little bit easier as it went through and cleared up some of your questions. It is very, very tricky unless you learn those rules for what goes where. Once you've got that down, what I suggest is you look at another video that I'm going to create, which is the exam practice, where we can look at electrolysis questions from an exam and work through them together. Hope this helped today. Thanks for watching. See you soon.